Hello, pre-calculus student. This video is continuing with application of exponential continuous function, and we are looking at decay now. So for continuous growth or decay, we have decided that we would just use the simple y equal to a0 e to the kt models, and then figure out how to find the amount after certain days and also half-life. Okay, and so we will in this video we'll do two applications that we related to radioactive decay or um, chemical compounds decay. Okay, um, example 5: a tumor is injected with 0.5 milligram of iodine 125, which has a decay rate of 1.15% per day. Okay, so we don't know half-life, but we know decay rate. So this is decay equal to 0.0115. So not 11.5, but because 1% is 0.01, you divide it by 100. So what is the function? So the function would be y equal to, initially is 0.5. E to the, because it's decay, the rate has to be negative 0.0115 t. Find the amount, use it to find the amount after 2 days. So t equal to 2, y would equal to 0.5, e negative 0.0115 t. So this is not finding time. They actually just want to find the value. So we use the formula, put in the calculator. So this would be 0.5 gram times second ln is E. Oh, sorry. 0.5 times second ln is E. Negative 0.0115 times 2, because they say 2 days, right? Because the rate is per day, yeah. So be 0.4886. Let's do 4 decimal place. It didn't say anything. 0.4886. It still has a lot of material there. Starting from 0.5, it just decay a little bit. What is the half-life? So we know half-life is ln, so h, right? Is ln 1/2 divided by the rate, which is 0.0115. Let's put in the calculator. So ln 1/2, 0.5, divided by 0.0115. Oh, actually it should be negative, the rate, because it's decreasing. So, let's do it again. ln, okay. ln, I think you just create the 0.5, because it's negative number, you need to divide it by the negative 0.0115. So that would be positive 60.27. Is it days? 60.7 days. 60.3 days. So it would decay. It takes 2 months to decay. Okay. Example 6: a person has a cup of coffee that contains 95 milligrams of caffeine. After 6 hours, the amount of caffeine is 41. So A0 is 95, but after 6 hours, then the amount y become 41. Okay, write the function that model the amount. So I don't know, they don't have half-life and they don't have k, so we need to find k, right? So what we do is we would have 41 y equal to a0 e to the kt. Y is 41, e to a0 is 95, e to the k. What is the time? Hours, 6 hours. So just like before, we divide 95, we divide 95. It's 41 over 95 equal to e of 6k. Right? So usually we solve for t in the last time, now we solve for k. Divided by, so we can do ln right away. So do ln on both sides, ln. So this would become ln 41 over 95 is equal to ln e to the 6k, but the 6k can move out. And ln e is 1, so ln 41 over 95 is actually equal to 6k. So k would equal to what? ln 41 over 95 divided by 6, and that's it. You put in the calculator. That would be it. 41 over 95. Great. ln 41, don't close, over 95. Now close and divided by 6. Huh? Oh, it's a negative. Negative 0.14005. Just do negative 0.14005. So it tells us that K is negative. Okay. What's half-life? We know half-life H is ln K. No, ln 1/2 divided by K. So our 1/2 would be 0.5. Our K was negative 0. Is it 0.14? 14005, do more 08 from the calculator. So ln 0.5 divide that. So I usually would save that number and then we do 0.5 and then divide. I'll go and copy and paste it in. So 4.95. Half-life is 4.95 days. Is it days or hour? Oh, hours. This is for caffeine. I think caffeine's half-life is more than that. Maybe this after 6 hours 41. This is too decaying too fast. Well, okay. So this is how you do it. So 47 is about half-life and decay also, but they tell you half-life, and then they tell you 20 years later what is the initial value. So, but they don't tell you the initial value. So we have to find it. After 20 years, so at equal to 20, then y is equal to 400, right? And this is h. So we can use y equal to a0 1/2 t over t, right? T over t to model it. And y is 400, so that means 400. And then a0 we don't know. And 1/2, we know the time. Time is 20. And over the half-life of 60. So h, t, t. Oh no, this is not h. This is h, half-life. Okay, erase this a little bit. T over h. T over h. Because yeah, so we would put in x equal to 60, t equal to 20. So that means 400. 400 is equal to a0 1/2 to the power 1/3. Okay, so to find a0, you just divide this number. So a0 would be, I'm going to divide this, so 1/2 to the 1/3 on both sides, right? 1/2 to the 1/3 would be 400 divided by 1/2 to the power 1/3, because 20 over 60 is just 1/3. Or you can just say 20 over 60. So put in the calculator, 400 divided by, open parenthesis, 1/2 to the power 1/3. It's a little clunky. 317. So that means the initial sample has what? 317? It doesn't make sense. Oh, I do 1 times 2 is wrong. 400 divided by, this is less, should be more. 1 over 2 or 0.5, right? To the power, open parenthesis, 1/3. When you do on your calculator, you should say 1 over 3. Always close it. Always parenthesis it. 503.968. 503.968. Okay. How long would it take to decay to 280? So we continue to use this. 280 is equal to 503.968 to the power 1/2. Um, hmm. T over, what was the decay rate? 60, right? T over 60. So we find T now, so have to divide by 503 over 968. Is it 968? Yeah. 280 divided by 503.968 is equal to 1/2 to the power T over 60. We will do log. Okay. Log of this. 280 over 503.968 equal to log, because it's not base E, T over 60. So the T over 60 can move out. Now we have log 280. This is you can see if you don't have E as a formula, it's hard. Equal to T over 60 and then log 1/2, log 0.5. Right? So to find T, we have multiply 60 divided by log 1/2. So T would be multiply 60 times log 280 over 503.968 divided by log 1/2. Wow. Okay, put in the calculator. 60 times it first. 60 times, and we have to do LOG. Time 60 times what? 280 log 280 over 503.968. And then close the parenthesis and then divide it by log 0.5. Close it. 50.87. There. And this is for years. Because after 20 years is 400. It started with 500. Yeah, that makes sense. It would be a lot more year to decay it to 280. Okay. Okay, what is the decay rate? So we know the half-life, which is 60 years. So K is very easy to do. ln 1/2 over 60. ln, because it's decay, right? 0.5. 0.5 over 60 over h. So you could in the beginning, like here when you solve it, always just use 0.011155. 5 decimal places. 1, 2, 3, 4, 5. Yeah. So you can check if you are to do check answer for that it is right to have 50 years, so you can check answer. It doesn't have to be. I just want to check that this makes sense. So if I start up with 503.96x and I do y of negative 0.01155 and then times 50.87 year, would I get 280? Right? So 503 point, what was it? 968 times e to the power negative 0.1155 oh, negative 0.1155 times how many year? 50.87. 50.87. You should have 280. Yeah. What was wrong? Let's see. 968 times, maybe it's this one. 0.088 times 50. Oh, there's a dot here. Delete 0.01155. Yeah, 280. So that works. You can see that you can use if you just calculate ln 1/2 60, you can use this formula to solve to find out how long it takes. It's longer if you keep on using the 1/2 things. Okay. So in the next video we'll do logistic model.